everyone. You guys are amazing. This is a fabulous class. Also, don't forget Class Connect sessions are recorded, okay? So with that, we have, today we're going to take what we did yesterday and we're going to put it together, and it's going to be very dense, very heavy today. And I apologize for that. I really do. It's not the funnest day today. It really isn't. But tomorrow, you have a work day, okay? Remember that roller coaster exam is not due until next Thursday, okay? But there is a recording that is available to you in your playback room for you to watch, and it will help you go through all of the math on the exam. Now, remember, oh, good. I'm so glad, Pacifico. Thank you. Yeah, you're good, Francisco. You're good. Do remember that video does not use the same numbers as on your test. Okay, so don't just copy down my examples because you're going to get the problems wrong. Use the numbers on the test, but how I work it out will show you how to do it, how to calculate it. Yes, Pacifico, thank you. Exactly. Thank you for helping me enunciate that. Okay, so today we're going to kind of put together what we did yesterday and show you how to actually do some of this math. And again, today is just super, super dense, and I apologize for that. So with that, I have just dropped the notes in the box. If you would, open that up. And we are going to learn how to calculate total mechanical energy today, okay? And be able to understand where some of these formulas come from, okay? So give me a thumbs up when you are done, when you have them opened and ready to go. Thank you, Jalea. Thank you, Sierra. Thank you, Errol. Thank you, Jenna. Thank you, Kira and Pacifico. Thank you, Pamela and Becky and Sophia. You guys are amazing. Sabrina, thank you. Thank you, Ace. Yay. Awesome. Christina, thank you. Awesome. Okay, I think we're ready. Here we go. So when we look at position and motion, right? So I know that potential energy depends on its position and the height of where it is, right? That's potential energy. Whereas kinetic energy depends on its movement, not so much on the position. So in the chat box, okay, tell me, okay, what percentage of total energy is potential energy if you are at the highest point of a hill and your car is at rest? 100%, exactly, 100%, yes, 100%. And if it's 100% potential energy, how much is kinetic? 0. Yeah, perfect, beautiful. Okay, now flip that. Let's flip that. And now we're at the lowest point, and we are going as fast as possible. What is the percentage of kinetic energy? Kinetic. The energy due to motion. Yes, yes, yes. 100%. Yes. Because it's going the fastest that it can possibly go, which means how much is left over for potential energy? Christina, yeah, 0. Perfect. Yes. Okay, now let's see if you can put this together. Okay, if we have a car sitting up here at the top of the hill and it is at rest, okay, it is at rest. It has 1,960,000 joules of potential energy, but it's just sitting up at the top. Okay. How much is it going to have when it gets to the bottom of the hill? How much energy will it have? How much kinetic energy will it have at the bottom of the hill? Drop it in the chat box. Tell me, what do you think? Low? Okay. Remember, we're talking about kinetic energy. Kinetic energy, right? So here, yeah. So remember over here, right? We said that, let's get this, 100% up here, right? So 100% up at the top is 1,960,000 joules of potential energy, right? At the bottom, kinetic energy is 1,000, right? So how much are we going to have down here? It's going to be it's going to be a lot, but how much? Can you tell me? 100%. Yeah. 1,000,000, I didn't even do that right. 1,960,000 joules of kinetic energy. Yeah. And I need to put another zero on there too. Yeah. So what was equal up here has now been transferred, all of it, to down here. Yeah. Right? Craziness. Okay. So all of that energy was transferred from potential energy into kinetic energy. It's crazy how that works. Okay. And that's why this equation works, right? So the total mechanical energy is potential energy plus kinetic energy. Yesterday, we learned the formulas for kinetic energy and potential energy. And you can see our new formula for total mechanical energy is just the potential energy plus the kinetic energy. Okay. So easy peasy lemon squeezy. Now, that is in an ideal system, meaning that there's no energy loss due to sound, due to friction, due to thermal energy, any of those things. Okay, so question number 2 is ideal. Question number 2 is ideal. Awesome. Hey, Gaba. Hello. Glad you could join us. Awesome. Okay. Thank you, Sierra. Thank you, Gata and Pacifico, Jenna, Maddie, Pamela, Tatiana, Kira. Thank you. Awesome. Thank you, Errol. Thank you, Jennifer. Perfect. Okay. So that was question number 2. So here is a word problem. Okay. We have a car driving at 5 meters per second on top of a tall hill at 120 meters. Okay, so let's go through here. Okay, and remember that kilogram is mass, right? Meters per second, that's my velocity. And then I've got meters, so that has to be my height, right? So to calculate the total mechanical energy of this car, right? I'm going to take the potential energy, or mass times gravity times height, and I'm going to add it to my kinetic energy. Okay, so now I'm just going to plug in my numbers. M is 850. Little g is always 9.8, a positive 9.8. Height is 120, okay? And then that's my potential energy, and I'm going to add the kinetic energy. Remember, we use the decimal equivalent of 1/2. Mass, again, is 850. And then our velocity from our word problem is 5 meters per second. Now, guys, this is where your math, knowledge, and algebra comes in to play, okay? So you have to remember PEMDAS, okay? Remember parentheses, exponents, multiply, divide, and then adding and subtracting comes last. So the very last thing we're going to do is add them together, okay? So on the left side of the potential energy, the left side of the addition, I need to multiply 850 times 9.8 times 120. Somebody in the chat room, grab your calculator, multiply those numbers for me, okay? What is 850 times 9.8 times 120? Somebody tell me, what is that? Yeah. Thank you, Sierra. Okay, so 999,600. Okay. Now, over on this side, again, according to PEMDAS, I have to do my exponents before I can multiply and divide. So I'm just going to bring down my 0.5. I'm going to bring down my 850. And then I'm going to do my exponent. So 5 times 5 is 25. Okay. So that is the kinetic energy part of the equation. So next, I'm just going to bring this back down. Okay. And then somebody grab your calculator and multiply for me 0.5 times 850 times 25. Thank you, Becky. Okay. 10,625. Okay. Now it's just a simple matter of adding them together. So somebody add those together. Okay. Tell me, did you get 1,010,225 joules? Yay. Excellent. Okay. So yes, Pamela, awesome. You got the same thing I did. Thank you. Good. So again, the formula looks horrendous, right? It looks scary. But if you just break it down step by step, it's really not that bad. Thank you, Pacifico. Francisco, you got that? Okay. Awesome. Okay. Everybody good? Thumbs up. Let me know. Are you ready? Woohoo! Party. Thank you, Sierra and Errol, Pacifico, Jennifer, Jenna, Kira, Najina, Pamela, Becky, and Sophia. Francisco, you got your hand up. You were just saying thanks. Good. Awesome. Thank you. Okay. I just love this class. I really do. Okay. Now this is where it starts getting tense. Okay. This is where it gets kind of crazy. The other part of total mechanical energy that comes into play is I can also break this down and say that point A is equal in mechanical energy as point B if I'm not losing any energy due to sound or friction, and it's in an ideal situation. Okay, so that allows me to write this equation that the total mechanical energy of this car on the side of this hill is equal to the same car on the opposite side of the hill. Okay, and if that's true, then I can write that the potential energy of point A plus the kinetic energy of point A is going to be equal to the potential energy of point B and plus the kinetic energy of point B. Okay. Whew. Now, what I'm going to do is instead of writing those symbols, I'm going to insert the chemical, or the, not the chemical, but the mathematical formulas for those in there. Okay. And now it looks super scary. Okay. So I'm going to simplify it just a little bit. If I look at these algebraic terms, okay, here's one term, here's another term, here's a term, and here's another term. What variable is repeated in every single term? What's in every single one of those terms? Is it the mass, the gravity, yeah, it's the mass, right? Do you see mass right there and right there, right there, and right there? Yes, exactly. And if you have the same variable in every single term, then one of the rules in algebra says I can cancel those out. And it's going to make my equation just a little bit easier. Okay. So that's a simplified mathematical equation. Also, question number 4. Notice question number 4 is equal. Point A, the TME of point A is equal to point B, the TME of point B in an ideal system, okay, where there's no energy lost. Give me a thumbs up. Let me know you're ready. Awesome, awesome. Thank you, Sophia. Thank you, Becky and Regina and Kira. Thank you, Errol and Francisco. Gata, Pacifico. Thank you, thank you, thank you. Christina, Sierra, and DC. Awesome. Perfect. Thank you, Pamela. Thank you, Joseph. Thank you, Sabrina. Perfect. Okay, you're tired but ready. Yeah, and this is where it really gets intense, guys, so I apologize. Okay, now, if I have a car sitting up at the top, okay, and it's at rest, okay, do you see where it says 0 meters per second, right? That tells me that there is no kinetic energy in that car sitting up at the top, right? Also, if I look at the bottom of the hill and I see that it is at the bottom of the hill, there's 0 meter elevation, I can cancel the kinetic energy for point A, and I can cancel the potential energy at ground level because there's 0, right? There's 0. And if I do that, then I can simplify this equation and get an equation that's a whole lot easier to use. Okay. So this is question number 5. Make sure that you identify little g times the height of point A is equal to 1/2 the velocity of point B. Thank you, thank you. Thank you, Sophia. Thank you, Kira. Thank you, Errol and Pacifico. Okay, everybody else, you guys got this? Thank you, Darwin. Thank you, Christina. Thank you, Francisco and Gata. Awesome. Jenna, Pamela, Becky, Yosef, Sabrina. Thank you, thank you, thank you. Awesome. Okay, so here is a problem, okay? And we're going to work this one out together, okay? And again, I'm going to kind of talk you through this. You guys have calculators at the ready, though. Okay, so on hill A, so this is point A, and this is point B. Notice that point A is on the left, right, and of the equal sign, and point B is on the right side, okay? So at the highest point of hill A, the height is 240. At rest, it is 0 meters per second. So 0 velocity, okay? At point B, the height is 0 and the velocity, oh no, no one knows. This is what I need to calculate and determine, is the velocity of the car at the bottom of the hill, okay? So here we go. Are you guys ready? Yeah. Okay. So little g is 9.8. Okay. The height of hill A is 240. Okay. Notice on the right side, my fraction has been converted into a decimal, right? And this is the variable I need to solve by itself. Okay. So I don't need to do anything on the right side of the equation yet. Somebody tell me, what is 9.8 times 240? Okay. Yep. What is 9.2? Thank you, Kara. So 2352, 2,352. Now, look at my directions, okay? The directions say divide both sides by 0.5. And that's because I need to get my variable by itself, right? So I am going to divide both sides by 0.5, okay? And when I divide both sides by 0.5, I can cancel this out, okay? And I'm going to be one step closer. So somebody tell me, what's 2,352 divided by 0.5? Excellent. Okay, 4,704. Now, it says square root. Dang it, guys. Okay, so I have to get rid of this exponent. Okay, and the way I get rid of the exponent is by using the square root. So here is how I'm going to share my screen with you again. Okay, and I want to show you using Google Calculator. I strongly encourage you, do not use your phone when you are taking a square root. Okay, if you look at Google Calculator, yesterday we talked about the exponent button. That's this one down here at the very bottom right of the gray squares. Okay, now right above it is the square root button. Okay, and if I want to take the square root of a number, for example, let's say 25, okay, I have to hit the square root and then put in my number that I want to find the square root of, and then I hit equal. So 5 times 5 is 25, so the square root of 25 is 5, and that's correct. So if I want to find the square root of 49, okay, I hit the square root button, I type in 49, okay, and then I hit equal. That should be 7. Now, watch what happens if I put in 49 and hit square root, okay, and then hit enter. I'm going to get an error message. And the reason is I have to have that number underneath the square root sign. Okay. So you don't forget to put the square root value or the symbol square root before the number, and then you hit equal. Okay. So that's how you use the square root button on a Google calculator. So somebody tell me, what is the square root of, yes, 4,704? And yes, it is 68.58. And I just rounded it up to 6/10. Okay. So this is similar to question number 5 on the test. This is question number 5. Different numbers. You have to use the numbers on the test, but the math is the same. The equations are the same. Take a screenshot of this. Okay, and this is again for question number 5 on the test. Okay. Give me a thumbs up. Let me know when you are done taking that screenshot. Thank you, Tatiana. Thank you, Kara. Thank you, Najina, Pamela, Jenna. Thank you, Errol and Pacifico, Jalea, Christina. Awesome. Again, on the test, don't forget, you can't just copy down the numbers, right? Because the numbers are different. Okay. You have to do your own math, but this is an example of how to do the process. Okay. Okay. Now, let's look at this example. Okay. I have a car sitting on a hill. It is at rest. And then I have, yes, solve and form your own equation. Exactly, Pacifico. Thank you. So I have a car at rest sitting up atop of the hill. Okay. Tell me, does the car have potential energy? Yes or no? If it's sitting on top of a hill. Yes. Yes. Good. Okay. If it's at rest, does it have kinetic energy? Yes or no? Yeah, no, it does not have any kinetic energy if it's at rest. Awesome. Good job. Okay. And that tells me on the left side of this equation, I can cancel out the kinetic energy, right? Now, look at point B. We're halfway down the hill. Okay. Does it have potential energy halfway down the hill? Does it still have some potential energy? Yes or no? Yeah. Absolutely, 100%. Because there's still some height to there, right? Yeah. Now, here's the question. If it's halfway down the hill, does it have kinetic energy? Yes or no? It's halfway. Yeah. Pacifico. It's moving. And if it's moving, it has kinetic energy. Exactly. Yeah. So on this example, the only thing I can cancel out is something on the point A. B has to have both potential and kinetic because it's only halfway down the hill and it's still moving. Yeah. Okay. Excellent. Good job. So this is question 6. Party. Okay. Let me know when you're done with question 6. Awesome. Thank you, Jalea. Thank you, Sierra. Thank you, Pacifico. Thank you, Jenna. Thank you, Kira. Thank you, Najina. Thank you, Rylan. Thank you, Sophia and Tatiana. Thank you, Yosef. Thank you, Becky. Love me some hearts. Okay. Perfect. Okay. So here is an example using, if we had a car at the top of the hill and something at the in the middle. Okay. So again, okay, if I were to label this, this would be point A and this is point B. On my formula, point A is going to be on the left side of the equal sign, and point B is going to be on the right side. Again, you can see right here, right? We've got those A's and B's that tell us which one goes with what, right? Okay, so I have a car, okay, and the height of the hill is 160 meters. So that, whoops, that is not the mass. That is the height of hill A. And the middle of the hill is 90 meters, okay? And again, notice that the velocity, okay, at point B, that is what I'm trying to find. That's my variable that I'm trying to find. So I'm going to have to do a square root again, right? Okay, so now it's just a matter of filling in these blanks, right? I know G, right? G is always 9.8. The height of hill A is 160 meters. Again, there's my equal sign. So now I'm looking at point B. G is always a positive 9.8 unless I'm working a free fall problem. The height of hill B is 90 meters. Notice that my fraction has been converted to a decimal, so I don't need to worry about that. And then here's my variable I need to get by himself. Okay, so somebody in the chat, tell me, what is 9.8 times 160? What do you guys think? With a calculator at hand. Excellent. 1,568. Perfect. Okay. And now on the right side, thank you, Kira. 9.8 times 90 is 1,568. Okay. Now I need to subtract from both sides. Okay. But subtract what? Okay. Notice that 1,568 is being added to these things that are being multiplied together, right? So I need to subtract 1,568 from both sides to help me get my variable by itself. Wait a minute. Wait, did I do something wrong? I did something wrong. What is 9.8 times 90? Yeah, that's what I did wrong. Kara gave me the same thing. And I assumed it was this one. That was my bad. You guys did it right. I did it wrong. Man, erasing this is a pain in my tush. So 9.8 times 90 is 882. Yeah, Pacifico. That was my bad. Yeah. Okay. So 882. 682, or is it? Oh, when you subtracted it. Yeah, 82. And then I'm going to subtract 882 over here. And Kira and Sierra, I should get 686. Is that right? 686. Okay. Yeah. Then I'm going to divide. So this answer comes down here, right? Okay, now I'm going to divide by 0.5 on both sides, just like I did before, and that's going to cancel. So what is 686 divided by 1/2? 1,300. 372. Okay. So the answer from this came down here. Now I have to take the square root of both sides, and that is going to get rid of my exponent so that my variable is finally by itself. So what is the square root of 1,737.04 joules? Exactly right. Exactly. Yes. Okay. So again, this is question 4. This is an example just like question 4. It is not the same problems, same numbers, but the math is the same. Okay. So don't use my numbers. Don't copy down these numbers because you're going to get the problem marked wrong. But the same process. Take a screenshot. Take a screenshot. Okay. Give me thumbs up when you have taken that screenshot. Thank you, thank you, thank you. Thank you, Sierra. Thank you, Errol. Thank you, Jenna and Kira, Pamela, Najina, Sophia, Tatiana, Becky. Thank you. Thank you, thank you, thank you. Awesome. Perfect. Perfect, perfect, perfect. So on the test, okay, you don't have to come up with all of it. What you have to do is you have to do the calculations and you have to put in the numbers from the test. Okay. Does that make sense? The formula is going to be there. The word problem is going to be there. And then you have to fill it in and do the math. Yeah. Yeah. With the numbers on the test. Yeah. I think Pacifico said it the best when you solve and form with, with your own, using your own math. Okay. Okay. So with example number 3, we have a car in the middle of the hill. If it's in the middle of the hill, we know it has potential energy and kinetic energy. This time point B is going to be at the bottom of the hill. At the bottom of the hill, does it still have potential energy or no? Tell me in the chat box, yes or no? No. You guys agree with Kura? Yeah. No potential energy at the bottom of the hill. Does it have kinetic energy at the bottom of the hill? How about kinetic energy? Yes. Excellent. Good job. Yeah. And so at the bottom of the hill, this is what type of formula you would use. Okay. At the bottom of the hill. Okay. Give me thumbs up when you are done with question 7. Thank you, Kira. Thank you, Pamela. Thank you, Sabrina and Sophia, Tatiana. Jenna, thank you. Thank you, Gata. Thank you, Pacifico. Thank you, Angelica, Christina, Sierra, and Jalia. Awesome. Okay. So with that, okay, tell me your last question. Okay. With this picture, you have a roller coaster that is at rest at the top of its highest hill. At rest. Do you need only the kinetic energy, only the potential energy, or both? Okay, this is going to be complete your own. Okay, and this, I believe, is the last question on your exam. If it is at rest, okay, Kira, it's at rest. Jalia, it's at rest. Pacifico, yes. Kira, yes. Yes, Jalia. Becky, yes. Sophia, it's at rest. Angelica, yes. Okay. Sierra, yes. Okay. Yay. Where's the quiz? Becky, what quiz? I don't know what quiz. Okay. Okay. No worries, no worries. Okay. So tomorrow, watch that in-depth explanation on how to do the math. Remember, don't use the same numbers that I'm using. Don't copy it. That's not what it's for. It's just to show you how to do it. Okay. So you need to do your own math. Use the numbers from the test. Okay. Antoine, I can go back to question 3 for you. Okay. So we are done. Are you feeling okay? That was dense. I know. A lot. Okay. Awesome. Good, good, good. Next Thursday, I will have office hours and I will be there to help you guys if you need me to help. Okay. Christina, yeah, yes. Awesome. Bye. You guys have a great day. Bye. Have a great day. Bye, Rylan, Pacifico, Pamela, Christina, Kira, Jalea, Becky, Jennifer, Angelica. Yeah, it'll help a lot. It'll help a lot. Bye, Michelle. Okay, Antoine, let's go back to question 3. Oh, it's not letting me go back to 3. Hang on a second. It's just going to take me a little bit. There, maybe now. Engagely is just not being very user-friendly today. There's number 3. Bye, Sierra. Antoine, you got it? So 1,010,225. Awesome. I hope you have a fabulous day. Bye. NYE. What's NYE stand for? NYE. Well, it's NYE. It says New Year's Eve. That's not it. Bye. Okay. I am going to sign out, guys. Okay. Unless you need me. Francisco, you good? Bye.